Have you ever really stopped to think about your blood type? I mean, it's so much more than just a letter and a plus or minus sign on a medical form. It's like this secret biological handshake happening inside you right now. So let's get into what that really means.
I mean, we all think of blood as this universal lifesaver. And a blood transfusion? It can be an absolute miracle, literally pulling someone back from the brink of death. But here's the crazy thing. If you get the wrong type of blood, your own body can launch this massive, all-out attack. It can be fatal. So what's going on here? How can one person's life-saving fluid be another person's poison?
And figuring this out wasn't just some academic puzzle. We're talking about real-world life-or-death situations, surgeries, severe anemia, major accidents. Getting a blood transfusion right is absolutely critical. A mistake is just not an option. Somebody had to solve this.
And thankfully, they did. The answer came right around the turn of the 20th century from an Austrian physician named Karl Landsteiner. He's the guy who finally cracked the code. And let me tell you, his discovery changed medicine forever. We're talking Nobel Prize level stuff here.
So what exactly did Landsteiner figure out? Well, he realized that our blood has this incredibly smart, super specific ID system. Think of it like a biological security checkpoint that's running 24/7. And to understand it, you just need to know the two main players. I like to call them the flags and the guards.
Okay, first up, let's talk about the flags. On the surface of every single one of your red blood cells, you've got these little molecules called antigens. The easiest way to think of them is like tiny little ID badges, or flags, that are constantly saying, hey, I belong here, I'm one of the good guys.
And then, of course, you have the security guards. These are your antibodies. They're just floating around in your plasma, and they have one job and one job only: to patrol your bloodstream, check those little flags, and immediately attack any that they don't recognize.
So here's how it all fits together. Your blood type, whether it's A, B, AB, or O, is just a combination of which flags you have on your cells and which guards you have in your plasma. And it's a really smart system of opposites. If you have the A flags, your body makes anti-B guards. If you have B flags, you've got the anti-A guards. It's a perfect little setup to protect you.
Now, this entire system works because of one really simple, elegant rule that Landsteiner figured out. It's like the golden rule that the whole security system runs on.
And here it is, the big secret. Your body never makes antibodies that would attack its own antigens. It just doesn't happen. I mean, think about it. That'd be like your security guards suddenly attacking the very people they're supposed to protect, right? It's this one simple rule that keeps everything stable. And it's also why introducing the wrong flags in a transfusion causes such a huge, violent reaction.
Okay, so that's the theory behind it. But how do we actually figure out someone's blood type in a lab? Well, it turns out it's a pretty clever, simple test where we basically force this reaction to happen right there on a glass slide, so we can see it with our own eyes. The principle is really straightforward. You take a little sample of someone's blood cells, and you basically challenge them. You introduce them to different kinds of security guards, these known antibodies, and you just watch to see what happens. It's kind of like showing a photo of a suspect to a lineup of witnesses to see who reacts. So what this actually looks like in a lab is you take a drop of blood and you mix it with a drop of something called anti-A serum. That stuff is just full of the security guards that hunt for A flags. Then you do the exact same thing in a different spot with anti-B serum, and all you're doing is watching for that reaction, for that sign that the guards have found their target.
And that reaction, it has a pretty cool scientific name, agglutination. Yeah, it's a mouthful, but it just means clumping. That clumping is the visual proof we're looking for. It's the sign that an attack is happening, that the antibodies are grabbing onto the red blood cells and sticking them all together.
And this diagram really shows you exactly what's going on. See those little Y-shaped things? Those are the antibodies. They're literally linking the red blood cells together, creating this big net, and that's what makes the clumps that we can see. That's the whole aha moment of the test.
So here's the best part. We can use this clumping reaction to figure out the blood type. This table is basically the decoder ring. It's super logical. If the blood only clumps when you add the anti-A stuff, well, it must have A flags on it, right? So you're type A. If it clumps with both, you've got both flags, you're type AB. And if it doesn't clump at all, no flags, you're type O. And we're not quite done yet. There's one more piece to the puzzle. We do the exact same test, but with a third serum called anti-D. This one checks for another flag called the Rh factor. And the rule is just as simple. If the blood clumps, the Rh flag is there and your blood type is positive. No clumping, it's negative. It really is that easy. Okay, so we've nailed down how we identify our blood type, but why does this one little biological marker matter so much? Well, as it turns out, its importance goes way, way beyond just making sure a blood transfusion is safe.
I mean, your blood type is a critical piece of the puzzle in so many different fields. We're talking forensic investigations at crime scenes, paternity disputes. It's absolutely essential for organ and tissue transplants, and it even helps protect newborn babies from something called Rh disease. It's this surprisingly versatile key to our own genetic code.